For 6 years, Germany mobilized all its industrial and scientific capacity to sustain its military strength. What they built were not merely tools of combat. They designed rockets, tanks, aircraft, and systems that, at the time, surpassed what any other country possessed. With that kind of resources, the war took on another dimension. But when the end came, that arsenal did not vanish immediately. Some pieces were abandoned in the midst of chaotic retreats. Others were still in transit when everything had already ended. Part of the material was seized by the victorious troops, while another segment was hidden, sunk, or diverted through unofficial channels. Many of those elements ended up in foreign depots in private hands, or reappeared in conflicts that had nothing to do with Europe. The years went by, and certain findings raised questions once again. Some objects were reused, others were never touched again. What really happened to the Nazi weapons after the Second World War? The last offensive, the extreme use of the Nazi arsenal in the fall of the Reich. In the final months of the conflict, the German army used everything left in its arsenals. It was not a planned retreat, nor a coordinated defense. It was an effort to halt the enemy advance with any operational piece, projectiles, tanks, planes ready for takeoff. What had been manufactured over the years was employed without reserve, in ruined cities, frozen mountain passes, and railway tunnels converted into defensive positions. On the Eastern Front, the Tiger tanks held out in East Prussia and near Königsberg. Thanks to their thick armor and long-range cannons, they temporarily stopped Soviet units. Even so, they were few, and fuel was scarce. Some were abandoned after damage or mechanical failures. Several were recovered by the Red Army and sent to Soviet territory for analysis. In the West, German units used self-propelled artillery and multiple rocket launchers from forests in the Ardennes. During the December of 1944 offensive, known to the Allies as the Battle of the Bulge, 150mm howitzers and short-range rockets were fired. Although they did not manage to change the overall course, they caused material damage and casualties among enemy ranks in Belgium. The Luftwaffe, still active, put the first jet fighters into service. The Me-262s managed to shoot down bombers over the Rhine. Although they offered greater speed, their effect was limited by the shortage of fuel and parts. Some of these aircraft were found intact by American troops in underground hangars in Bavaria. In the streets of Berlin, German battalions used portable rocket launchers, mines, and automatic rifles. The Sturmgewehr 44 was used by inexperienced militiamen. Its compact design and firing capability made it useful in confined spaces. Some were collected by the Soviets and later examined for replication. From platforms in the Netherlands, V-2 rockets were still being launched at London, Norwich, and Antwerp. They were imprecise, but their speed and range were surprising. In the last 5 months of the conflict, more than 3,000 were fired. At the end of the war, the bases were taken by British forces, and part of the unused material was transferred to laboratories for study. In Norwegian waters, Type 21 submarines were being prepared for long-range operations. These models could remain submerged longer than others. They did not see combat. 2 were captured by British forces and analysed for later naval development programs. In northern Italy, German soldiers used shaped charges, light weapons, and anti-tank projectiles to stop the Allies near Bologna. They also used improvised mines made with industrial materials. In cities such as Bolzano and Murano, they adapted to urban combat using weapons originally created for fast offensives. In the last days of April, Berlin was the scene of a final resistance. Anti-aircraft guns were used horizontally against Soviet armored vehicles, and unexploded rockets were used as mines. Many of these weapons were destroyed or left among the rubble. Those that survived were sent to Moscow or Washington for examination. After the occupation, a meticulous classification began. Every tank, rifle, or rocket in good condition was recorded, packed, and transferred for technical analysis. The tests began shortly thereafter in laboratories and proving grounds of the Allied countries. Seizures in chaos, the war booty that failed to escape. As the Axis lines collapsed, many weapons were still in use, in transit, or even in production. The fall of the Third Reich was not immediate. Between March and May of 1945, factories continued operating. Trains crossed the territory with military material, and some officers attempted to regroup units in still defended zones. Amid that chaos, Allied forces began intercepting equipment before it could be used or hidden. In the east, during the fighting in Silesia, Soviet troops seized operational vehicles, self-propelled guns and precision rifles in large quantities. Not all were stored. Some were found along escape routes and at stations. When surrounded, German columns abandoned their cargo to continue on foot. There were even trains taken without resistance. One of the most significant discoveries was the underground plant of Mittelwerk in the center of the country. There, 5.2 rockets were still being manufactured. Upon entering, American soldiers found more than 500 units in various stages of assembly. Alongside them were blueprints, molds, guidance systems, and newly assembled engines. Some engineers were detained, others had escaped. The components were quickly transferred to facilities in the United States. In other regions, British troops found camouflaged hangars with half-loaded jet fighters. In Schleswig-Holstein, an airstrip contained Me-262 models with fuel and armament ready. Some were dismantled on site, others transported whole to the United Kingdom. There, flight tests were conducted to assess their behavior. The extracted data was later applied to new models of British military aviation. In southern Germany, American units took control of underground depots that contained unused chemical weapons. They were stored in sealed containers and ready for shipment. The documentation included routes to facilities in Czechoslovakia, indicating that their distribution was still planned. These stockpiles were removed under guard and later buried. At the same time, French forces advancing from Alsace found operational Panther tanks. Some were repaired by local technicians and used in the French army during the post-war period. The manuals found and the spare parts allowed them to remain active for years. The Red Army also located mobile laboratories and wagons with radar systems, advanced radios, and unfinished prototypes. Many of these pieces of equipment were sent by train to research centers in Ukraine and Belarus. The main interest was to understand their functioning and determine if they could be adapted to their own needs. Part of this technology was reused in subsequent decades. In the Bavarian Alps, a convoy stopped by American forces was transporting rocket parts, aviation engines, and technical documentation. Those responsible tried to destroy the load, but only part was hit. The rest was classified. This type of seizure allowed the Allies to access technology that had not yet been deployed, but was nearly ready. In rural areas, the accelerated retreat left behind intact warehouses. In villages near the Swiss border, cellars were discovered containing new rifles and boxes of ammunition. Some were collected by passing troops, others remained under the control of the new authorities. In a few months, everything that was not destroyed changed hands. Vehicles, projectiles, night vision systems, radios, engines and tools were loaded into trucks, trains and planes bound for test fields and arsenals in the victorious countries. These seizures were planned. Often, Allied technical teams accompanied combat units to identify and secure what was valuable. Their inventories included everything from long-range rockets to sights and basic mechanisms. The goal was not only to recover weaponry, but to thoroughly study how it had been designed. Unexpected replicas, how the West reused German power. After seizing Nazi weaponry from factories, transport routes and combat zones, the victorious countries did not store it as relics. They began to use it. The technology developed by the enemy was transferred to training grounds, air bases and laboratories. Tanks, rifles, missiles, fighters and submarines were studied, modified and tested by technicians from the Allied armies. In the United States, a considerable portion of the V-2 rockets was sent to New Mexico. There, at military facilities, they were reconstructed with the help of German engineers, now under supervision. More than 70 experimental launches were conducted. The results helped to adjust trajectories, refine guidance systems, and prepare new models of medium-range missiles. The United Kingdom conducted similar tests. At the Farnborough base, British technicians flew Me-262 fighters that had been seized nearly intact. Air Force pilots performed maneuvers and evaluated their behavior. What was observed was incorporated into the design of subsequent aircraft such as the Gloucester Meteor. France also made use of part of the material. During the reconstruction of its armed forces, it incorporated Panther tanks recovered on national territory. Some were reconditioned, repainted, and employed by armored units. In comparative tests carried out near Paris, military technicians confirmed that they had specific advantages in certain types of terrain. The Soviet Union opted for a broader strategy. Entire factories were dismantled and transported by train to industrial areas in the interior. The replica of the V-2 rocket, called the R-1, was built from confiscated parts and blueprints. Detained German engineers collaborated with local personnel in the first launch tests. In parallel, versions of the Tiger II tank and automatic artillery systems were studied to integrate those ideas into new Soviet weaponry. In Norway, German Type 21 submarines were examined by the British Navy. The aim was to understand the prolonged submersion duration, mechanical stealth, and improved autonomy. These principles influenced the designs of the following decades, both in American and Soviet vessels. Other captured systems included guided bombs. The Fritz X, used by Germany in the final months of the war, was analyzed by American technicians. Its remote control mechanism and stabilized descent became the basis for early versions of modern precision munitions. Experimental munitions were also tested. At artillery ranges, sub-caliber projectiles, shaped charges, and models designed to penetrate armor were disassembled and evaluated. Technical reports compared their performance with Allied standards. Some of these characteristics were later incorporated into conventional weapon development programs. Even light weapons were assessed. American soldiers trained with MP-400 submachine guns and Sturmgewehr rifles to test their reliability, firing rate, and ease of use. These tests helped define details that would later be implemented in models such as the M16. The process was not limited to military use. Companies linked to the defense industry also accessed parts, plans, and materials. Manufacturers of aviation, electronics, and metallurgy received batches to analyze practical applications. Part of that knowledge was adapted to industrial processes unrelated to combat. Even damaged equipment was utilized. What could not be reused for firing served for repair practices, technical training, or resistance tests. The seized material was transformed into a learning tool regardless of its origin. Black market Nazi weapons in wars of other countries. When the conflict in Europe ended, thousands of German weapons remained outside the direct control of the victorious armies. Some were taken before being inventoried. Others were sold by soldiers, officials, or intermediaries who understood their value beyond the battlefield. Thus began the unofficial transfers of rifles, cannons, vehicles, and complete systems from Third Reich depots to conflicts in other regions. In the Middle East, several factions incorporated German weaponry before the end of the 1940s. Armed groups in Palestine, Syria, and Egypt used Mauser rifles, MP-400 submachine guns, and MG-42 machine guns. Some pieces came from abandoned depots in North Africa. Others arrived via intermediaries who crossed the Mediterranean without customs controls. During the Arab-Israeli War of 1948, the use of German projectiles, mortars, and Luger pistols was reported among various ranks. The weapons were operational and, in some cases, locally modified. British reports confirmed that part of the material did not come from their own arsenals, but matched German models recovered after the surrender. In South America, the situation took another turn. German officers who had taken refuge in Argentina and Chile established links with local military structures. Through this route, weapons, blueprints, and technical knowledge were shared. Some training units in Argentina incorporated German-made machine guns and rifles during the 1950s. Instruction materials also included manuals and technical catalogues in the German language. In Africa, colonial powers transferred German weaponry to local units during independence wars. Mauser rifles were used in Algeria and MG machine guns in areas of West Africa. Although they were not new models, their durability and power made them useful in irregular combat contexts. Some remained operational until the 1970s. The European black market facilitated other routes. Thousands of weapons were extracted from Germany via uncontrolled trains, private vehicles, and clandestine networks. Some ended up in the hands of armed groups in the Balkans. Others were sold in cities like Marseille, Naples, or Vienna, where former combatants and traders exchanged them for money, valuables, or political favors. In Asia, part of the material reached Indochina. French troops in Vietnam reused German rifles, grenades, and communication systems. Many of those pieces had been transferred as surplus or redistributed among Allied armies. Although not modern weaponry, they functioned effectively in jungle combat or mountainous regions with limited infrastructure. In scenarios without direct state participation, Nazi weaponry also found use. Paramilitary groups in Eastern Europe employed leftover German pistols, grenade launchers, and explosives. Some of these weapons were used in clashes against new communist authorities. The exact origin of the material could not always be traced by local security services. Certain shipments did not go through sales channels, but were transferred based on ideological affinity. Some fleeing German officers offered weapons to sympathizers in exchange for help, documents, or shelter. Although there was no centralized coordination, these networks allowed part of the material to remain beyond the reach of occupying forces. Over time, tracking these pieces became increasingly difficult. Some were modified or mixed with national arsenals. Others were stored, abandoned, or destroyed in later battles. The circulation of this weaponry outside official records was widespread and left traces in various regional conflicts. Missiles, jets, and speed machines, what they didn't know would work. In the final years of the war, the Nazi regime promoted developments that defied the technical standards of the time. These included faster aircraft, longer-range rockets, and prototypes that surpassed known military capabilities. Some were used in a limited way, others remained in the testing phase, but once evaluated by the victors, their designs marked the beginning of a new technological era. The most representative case was the V-2 rocket. Built as a weapon of retaliation, it was launched against cities such as London, Liège, and Antwerp. Its accuracy was low, but its speed and range made it the first functional ballistic missile. After the surrender, the United States and the Soviet Union recovered parts, schematics, and personnel from the program. At White Sands, more than 60 V-2s were launched between 1945 and 1950. Each test helped refine guidance systems and calculate trajectories for future medium-range missiles. American technicians not only documented the launches, they also integrated the data into theoretical models that would later influence space programs. At the same time, the Soviet Union produced an exact replica of the V-2, named the R-1, which was launched in 1948 from Kapustin Yar. Although it was a direct copy of the German model, its development enabled progress toward other missiles. The acquired technology was quickly incorporated into nuclear deterrence programs. Another breakthrough was the Me-262, the first operational jet fighter. It was deployed in the final months of the conflict and managed to intercept Allied bombers. With a speed exceeding 800 kilometers per hour, it was difficult to counter. However, its limited numbers and lack of spare parts reduced its effectiveness. At the end of the war, several units were captured by British and American forces at bases in Bavaria. These units were transferred to testing centers such as Wright Field and Farnborough. Allied pilots examined them in actual flights, documenting maneuvers and performance. The collected data helped design new models, such as the F-86 Sabre in the United States and the Gloucester Meteor in the United Kingdom. In both cases, elements of the turbine system, weight distribution, and high-altitude response were incorporated. Another notable project was the Horton Ho 229, a flying-wing aircraft made of wood and shaped to reduce radar detection. Although it never entered combat, one of the prototypes reached the United States intact, where it was evaluated by Northrop engineers. Its design influenced later studies on stealth aircraft. Decades later, some of its features would appear in experimental models of the B-2 program. On the ground, experimental vehicles like the Panzerkampfwagen 8 Maus were captured. This nearly 200-ton tank was built in 2 units. Although it did not participate in battles, one was sent to the Soviet Union to analyze its mobility, durability, and fuel consumption. The information was used in tests on the structural limits of heavy armor. Unconventional projectile designs were also evaluated. The Rheinbote, a long-range artillery rocket, was tested in Belgium. Its performance was studied by the Allies, who were interested in its staged propulsion system. Similarly, the Ruhrstahl X-4 air-to-air missile, guided by wire, was analyzed by Soviet and American technicians to understand its control mechanism. These observations influenced the initial development of infrared-guided missiles. The Bachem-Bar 349 vertical interceptor, piloted by a single person, was another example reviewed. Although the project was cancelled after a few flights, the data on its acceleration and launch served as a reference for manned rocket research. Some of these experiments inspired later studies on individual launch vehicles. That list was joined by lesser-known models, such as the DFS 346, a supersonic glider designed for high-altitude flights. Although the prototype was captured untested, its blueprints were used by the Soviets in advanced aerodynamics studies. Reports were also found on the Skoda Kauba, an experimental aircraft project with detachable wings aimed at combining maneuverability and speed. Although its development was never completed, its ideas were reviewed by engineers in Prague and later archived by Allied technicians. In the naval field, guided torpedo designs and compact propulsion systems were studied, later influencing the design of tactical submarines. Each of these pieces, though fragmentary, offered a clue about the direction the German military industry sought to take. The transition of these systems into study objects was not immediate. Many were disassembled, analyzed, and evaluated over weeks before conclusions were drawn. Even so, they altered the way armies approached weapons research. Some technologies could not be applied immediately due to failures under real conditions, technical limitations, or lack of materials. However, they offered viable models for future developments. Researchers were not looking for already effective weapons, but for ideas that could become useful tools in future scenarios. Chemistry in reserve, the toxic arsenals they never dared to use. During the German retreat and the enemy's advance on the cities, part of the Nazi weaponry was never deployed. These were chemical compounds developed for warfare, which, despite being produced in large quantities, were never used. Some were known from previous wars, while others belonged to a new category, with faster and deadlier effects. Their existence was confirmed after the conflict. In underground depots in Silesia and Thuringia, Allied troops found drums labelled with names such as tabun, sarin, and soman. These agents had been developed in German laboratories during the 1930s. Unlike the gases of the First World War, these did not merely cause irritation or blindness. They were neurotoxins that interrupted nerve transmission, causing death within minutes. Minimal contact was enough to be lethal. Their production was kept secret. The factories were far from urban centres, operated under military supervision, and staffed by specialists. One of the most important was located in Die Herrnfurth, near Breslau. There, several tons were produced each month, stored in metal cylinders and transported by train. At the end of the war, the British found more than 5,000 tons of these compounds ready for distribution. Despite having the capability to use them, these weapons were not deployed at the front. The German command avoided their use, possibly due to fear of retaliation, since the Allies also had chemical arsenals and had warned they would respond immediately. Another obstacle was logistics. Their use required controlled conditions and trained personnel, something difficult to guarantee in the final months of the conflict. Some documents suggest that orders were issued to use them if Berlin fell, but they were never executed. Instead of activating them, they were hidden in bunkers, tunnels, and wagons. Their existence was only confirmed when occupying troops began inspecting the facilities. In many cases, Allied technicians were unaware of the contents until the compounds were identified through abandoned technical documents. The Soviet Union found similar arsenals in areas of eastern Germany and Poland. Part of these materials was sent to military laboratories for analysis. From them, chemical defense protocols were improved and fast-acting antidotes were designed. Western countries followed similar paths. The United States, for example, stored some of these agents in secure facilities and analyzed their behavior under different conditions. In certain cases, the containers were deemed too dangerous to handle. As a result, the decision was made to sink them. Decommissioned ships were loaded with chemical weapons and taken to deep waters in the North Sea and the Baltic Sea, where they were sunk in a controlled manner. These operations, recorded by the involved governments, were not publicly disclosed at the time. Subsequent studies indicated that these agents were among the most potent ever developed. Their use in combat would have caused uncontrollable consequences, both for the enemy and the civilian population. For that reason, the acquired knowledge was applied more to defensive preparation than to incorporation in active arsenals. In addition to neurotoxic agents, compounds were found that were designed to contaminate water, damage fuels, or affect crops. Although not directly lethal, they would have caused large-scale logistical and health problems. Most were still in the experimental phase, but they indicated an intention to expand the use of chemistry beyond direct combat. The laboratories responsible for these weapons were dismantled. Some personnel were interrogated, and a few later collaborated in classified research programs in the United States, the United Kingdom, and the Soviet Union. The recovered documentation was used to establish regulations on hazardous materials and served as a basis for non-proliferation agreements. ghost depots, the Nazi cargo buried beneath Europe. As German troops retreated and cities fell into Allied hands, plans were set in motion to hide weaponry. It was not an improvised action. Orders had been issued to move military material to tunnels, mines, underground depots, and wooded areas far from the fronts. The purpose was to prevent systems still in testing or in reserve from being captured. Part of them was found in the following months. Another portion remains untraced. In Jonostal, Thuringia, an incomplete tunnel network was discovered. Inside were wagons with rocket engines, boxes of electrical components, and reinforced structures ready to store sensitive material. No military personnel were present. Only traces of civilian staff who abandoned the site before the Soviet arrival remained. The recovered plans suggested it was a facility prepared to operate underground for an extended period. In the Bavarian and Austrian mountains, Allied patrols located camouflaged entrances on hillsides. Many were mines adapted to store weapons. Packed rifles, armored vehicle parts, and projectiles arranged in compartments were found. Some galleries were deliberately flooded, others sealed with concrete. Reports indicated these were structures designed to preserve material in stable conditions for years. Near the border between Poland and Czechoslovakia, the Soviets found immobilized trains in sealed railway tunnels. Some wagons contained ammunition, others aviation parts, tactical radios, and light weapons. Many boxes still had their seals. The origin markings indicated they had been manufactured shortly before the fall of the regime, destined for imminent distribution. Hidden arsenals were also found in the basements of official buildings, monasteries, and farms. Several local residents reported odors, strange structures, or stories from the era. In Berlin, beneath public offices, passageways with numbered boxes were accessed. Inside were pistols, uniforms, and technical documents meticulously packaged, as if awaiting later recovery. Some of the material was not buried but sunk. In the North Sea and the Baltic Sea, ships were loaded with projectiles, mines, and hazardous substances, and then submerged in deep zones. These operations were carried out both by retreating Germans and by occupying forces. In some cases, the ships were sunk intact. In others, charges were detonated after descent to prevent any rescue attempts. Marine studies conducted decades later located some of these sites. Sunken structures were detected thanks to magnetic anomalies or reports from fishermen. Inspections confirmed that they still contained war remnants in various states of decay. For safety reasons, no recoveries have been made. The risks outweigh any potential retrieval. There were also unexpected findings. In forests of Saxony and Brandenburg, occupying forces unearthed weapons covered with tarps, buried at shallow depth. Most were rifles, machine guns, and hand explosives. They were not identified or accompanied by documents. Everything indicates they were hidden without formal coordination as part of disorganized retreats. Some were used by irregular groups, others remained hidden for decades. In Czechoslovakia and Hungary, wagons with artillery parts and radar systems were located. Most were in abandoned workshops or disused rail lines. Some items had been sabotaged, others were in acceptable condition and were used in technical tests or dismantled for evaluation. Not all locations were identified. Files published many years later mentioned tunnels, trains, and storage sites whose existence has not been verified. Some may have been destroyed, others lost due to changes in the terrain or lack of detailed information. Hidden technology, advanced projects lost in time. In the final years of the regime, groups of German engineers worked on combat systems that were not yet ready for use, but which surpassed what other powers knew. Some of these developments never moved beyond the design stage. Others were partially built. When Allied forces entered German territory, they found documents, sketches, and parts that did not resemble already deployed weapons. These ideas, although never used in combat, were transported abroad and studied for years. One of the most frequently cited programs by occupying troops was the so-called Die Glocke. Although no complete device was found, documents and testimonies collected in areas of Silesia and the Sudete described a cylindrical object that contained mercury and was surrounded by materials with electromagnetic properties. Reports spoke of strange behaviors during its use, such as electrical interruptions or unusual physical reactions. There was no certainty about its function, but the documents were sent to analysis centers in the United States. Some of the involved personnel were interrogated for months. Another significant find was the Orton Ho 229 aircraft. Its triangular shape, lacking vertical fins, reduced its radar visibility, though that was not its initial purpose. Several test models were built. One was found by the Americans and taken to specialized laboratories. Its design was reviewed by aerospace companies and served as inspiration for later developments. Years later, its lines would be revisited in low-observation aircraft projects. In the field of propulsion, German technicians had explored the use of mixed fuels and engines with adjustable thrust. Some designs were aimed at surface-to-air missiles with rapid response capability. The Wasserfall model, derived from the V2, was equipped with remote control and could explode near the target. Although not produced in large quantities, its principles were analyzed by British and Soviet experts. These concepts would be reused in later generations of missiles. Plans were also found for projectiles using electric energy for launch. No working prototypes existed, but the diagrams detailed railguns capable of firing without explosives using magnetic fields. The documents were archived and shared with high-level physicists. At the time, they were considered impractical, though in later decades some countries revisited these ideas with more advanced materials. Other files described long-range optical devices, microwave emitters, and tools designed to interfere with enemy communications. Although these were initial developments, they showed a clear intention to affect adversary electronic systems. Some of those concepts resemble technologies that would later be known as signal jammers, electronic countermeasures, or passive radar systems. In the Harz Mountains, US troops found fragments of a project that combined vertical ascent engines with sealed capsules. Although full documentation was missing, technicians suggested it was an attempt at a high-altitude launch vehicle. The materials used, lightweight and heat-resistant, drew the attention of specialists already working on strategic missile programs. In Prague, records were found of experiments with concentrated thermal energy. The documents spoke of devices capable of focusing heat on a single point using lenses and powerful generators. There was no conclusive proof or imagery, but the descriptions were deemed relevant and preserved by Allied research centers. Not all of these developments were intended for direct combat. Some reports referenced concealment techniques, such as fabrics treated with substances that reduced visible body heat or paints that absorbed light. Although no physical samples were found, the notes were detailed and used precise terminology. These documents were forwarded to groups studying infrared systems. Efforts focused on individual mobility were also detected. In certain hangars, suits equipped with small propellers were discovered, designed for use by soldiers during high-altitude descents. Notes indicated the tests were at an early stage. However, the possibility of giving a combatant independent flight capability was taken seriously by the military departments of various powers. These materials were not destroyed. Even though many were incomplete, all were considered valuable. The papers, parts, and samples were distributed among state agencies, technical universities, and companies linked to defense projects. They were organized according to their development stage, potential practical application, and connection to other existing programs. Some remained stored without immediate use. Others became the foundation for future research. Stolen industry, the global race for the Nazi brain. After Germany's surrender, part of the seized military material was classified and distributed among defense institutions. However, a large portion of the technical knowledge ended up outside the barracks. Private companies, without mentioning the source of the material, incorporated these ideas into their industrial processes. German weapons, their components and operational principles passed into the hands of companies without uniforms but with access to blueprints, laboratories and materials. In the United Kingdom, reports from the British Intelligence Objectives Subcommittee indicated that firms in the aerospace and metallurgical industries received components such as engines, hydraulic systems, and fuselage structures for analysis. The goal was not direct copying, but rather adapting the useful elements to existing production lines. In several cases, those components were modified for use in industrial machinery, civilian turbines, or transport vehicles. In the United States, a similar situation occurred. Companies linked to the government, such as General Electric, Bell Aircraft, North American Aviation, and Westinghouse, gained access to documents and parts from German plants. In their workshops, engines, control devices, propulsion systems, and measurement instruments were dismantled. All this information was systematized and applied in new prototypes, later registered as American intellectual property. Many adaptations focused on materials. The use of lightweight metals, heat-resistant coatings, and anti-corrosion techniques was one of the most beneficial contributions for the industrial sector. Manuals found in German factories explained thermal treatment processes and chemical mixtures that were little known outside the country. With these methods, companies improved the resistance and efficiency of their products without needing complete redesigns. There was also application in the pharmaceutical field. Laboratories collaborating with government agencies had access to medical studies conducted by German researchers. Although some were ethically questionable, the data on physical tolerance, reaction to substances, and metabolism under stress were considered useful. Some formulas developed for pilots or submariners were transformed into civilian products, with no trace of their origin. The automotive sector also benefited. Suspension designs, transmissions, and chassis structures that offered greater stability and durability were adopted. Several of these systems had been tested in German prototypes that never entered combat. Patents originally registered by brands like Henschel or Daimler-Benz were transferred to foreign companies that modified them for commercial post-war use. Reports compiled during the occupation reveal that many patents were absorbed without acknowledging their origin. The victor's justification was clear. As the property of a defeated state, there was no obligation to compensate. Thus, hundreds of technical developments became part of private companies' catalogues without any legal intermediaries. In the Soviet Union, this process was more systematic. Several factories were dismantled and completely relocated to Soviet territory. There, local workers continued producing parts based on German blueprints. At the same time, state research centers received documentation and prototypes to adapt those solutions to Soviet standards. This knowledge was applied in sectors such as railroads, aerospace, electrical systems, and precision optics. In neutral countries, the integration was more discreet. Some Swiss, Swedish, and Spanish companies, which had maintained commercial ties with Germany during the war, retained access to technical materials. After the conflict, these resources were incorporated without raising suspicion. Often the origin was hidden through minor redesigns or new patent registrations with later dates. In West Germany, part of the military industry was transformed into civilian production. Some companies changed names, adjusted their legal structure, or diversified their activities. However, among their documents remained formulas, drawings, and methods created during the conflict. Although the surrender treaty prohibited rearmament, that knowledge did not disappear. Years later, some of it was used again under official contracts from the new German government. The technology transfer was not limited to objects. It also occurred through people. Engineers, designers, metal specialists, and scientists with practical experience were hired by companies seeking immediate solutions. These professionals, who wore no uniform and had no criminal record, contributed improvements, manufacturing methods, and testing techniques not found in any official manual. In many cases, their contributions were never linked to their true origin. Tunnels, remains, and secrets, the relics still emerging. Decades after the end of the war, discoveries began to surface that brought back into the present parts of Nazi weaponry once thought lost. Some were found by chance, others after investigations guided by old documents, persistent rumors, or signals detected using new technology. These findings, scattered across several countries, showed that a significant portion of the hidden material had not been located and remained buried, submerged, or sealed. In a wooded area near Pilsno in southern Poland, workers expanding a secondary road uncovered a collapsed entrance. Upon inspecting the site, they identified a room with rusted shelves, still containing rifles, helmets, and ammunition boxes. The access had been sealed from the inside, suggesting that those who prepared it never returned. Despite the deterioration, the items retained German manufacturing marks and dates corresponding to 1945. On the outskirts of Kassel, Germany, during work on an abandoned industrial plant, compartments were found containing rocket components and well-preserved blueprints. Among the materials were guidance systems and schematics for short-range missiles. Specialists reviewing them associated the designs with a project similar to the Wasserfall. There were no official records of that facility, indicating it operated outside central control. In Austria, a group of researchers located sealed wagons on a railway line buried after the war. Inside were artillery parts, spare components for armored vehicles, and unused uniforms. The site was identified thanks to a family diary. Examination of the contents showed that the train had been halted by direct order of local commanders, intending to return for the material later. Off the coast of Latvia, fishermen reported metal structures damaging their nets. Divers and technicians located the remains of a sunken vessel with numbered crates. Some contained sealed projectiles, others containers with barely legible labels. The cold temperatures and depth had slowed corrosion. Analysis indicated the cargo was part of an incomplete evacuation operation. In the Baltic Sea, unmanned submersible vehicles detected zones with high concentrations of metallic objects. There, remains of ships with military material were identified, some containing sealed cylinders similar to those used to store chemical agents. Though the contents were not retrieved, water samples confirmed the presence of residues consistent with warfare compounds. Near Trondheim, Norway, a sealed cave was found containing glider fragments, partially dismantled engines, and precision tools. The location did not appear in known military documents. Its remoteness and difficult access explain why it had not been discovered during initial inspections. Part of the contents was sent to a local museum, while the rest remained with technicians for further analysis. In the Czech Republic, archaeologists excavating near a former training camp found remains of an underground structure. Inside were radio equipment, generators, and unused ammunition. Examinations indicated the facility had been built in the final months of the war. The entrance had been covered by vegetation and stones, which had prevented earlier identification. Declassified files from Allied governments revealed references to uninspected or only partially reviewed installations. Some documents mentioned tunnels in rural areas of Germany and Austria that were never explored due to lack of resources. They also referred to diverted trains whose final destinations were never recorded. This information spurred private expeditions and television programs that attempted to trace the routes of those shipments. The development of tools such as geological scanners, satellite imagery, and historical map comparisons made it possible to locate buried structures in previously inaccessible areas. In several cases, ground-penetrating radar detected chambers beneath buildings constructed in later decades. Some were opened with authorization, others await excavation. In private collections and international auctions, items began to circulate without clear documentation. Dismantled cannons, aircraft fragments, and electronic equipment were sold with certificates of authenticity. Some objects ended up in museums, others in the hands of collectors. This circulation, permitted in certain countries, raises questions about their origin and how they exited official inventories. The discoveries were not limited to Europe. In regions of South America, North Africa, and the Middle East, German weapons still appear in forgotten arsenals, private properties, or unregistered depots. Though they are older models, their existence confirms that Nazi armament spread more widely than initially estimated. The findings continue. Each adds a piece to the incomplete map of the material developed and hidden in the war's final months. Many of those elements were never used, sold, or destroyed. They were simply stored, waiting. Not everything built by the Third Reich was destroyed when it fell. Some of it was scattered, some buried, and some vanished without a trace. The most sophisticated weapons became part of secret programs. The more common ones were sold, used, or simply disappeared. Some laboratories changed countries without changing their purpose. In certain regions, material continues to be found where no one expected it, sometimes at the bottom of the sea, sometimes behind a forgotten wall. Many of those remnants were reused without mention of their origin. Others were studied, copied, and archived. Some pieces operated again under another flag. Others remained stored, whether out of precaution or neglect. Although years have passed, the circulation of that arsenal was never fully closed. In areas of the North Sea and the Baltic Sea, more than 40 ships were sunk carrying cargoes that included mines, projectiles, and chemical weapons. On some coasts, the remains are still there, never opened or inspected. In underground depots in Silesia, more than 5,000 tons of agents such as tabun and sarin were found, ready for transport. At White Sands, the United States launched more than 60 V-2 missiles between 1945 and 1950. At the same time, the Soviet Union replicated the model under the name R-1 and tested it at Kapustin Yar. In both cases, these were not isolated tests, but the foundations of new missile systems. Even decades later, rockets, tanks, and documents were found in blocked tunnels, sealed caves, or abandoned tracks. What began as war booty or abandonment became part of modern weaponry. What remains unfound continues to raise the same question as in the beginning. Do we really know where all the weapons left by Nazism are?